Assalamu alaikum warahmatullahi wabarakatuh. Today's lesson about how to use the L'Hopital rule to determine the limit instead of some previous ways. Today we're gonna learn how to determine the limit of indeterminate type, the L'Hopital rule, the common mistakes, some examples about the L'Hopital rule, indeterminate product, indeterminate difference. And we're gonna cancel the indeterminate powers, and finally we're gonna take a summary. So today's lesson, how to determine the limit for the indeterminate type. So Mr. For the determinate type, the determinate type means the limit will be has a value whatever it's real, like 4, 8, 1 over infinity, which is 0, or undefined value like 1 over 0 or infinity over infinity or negative infinity over negative infinity. For the second part, we're gonna use the L'Hopital rule instead of some previous rules. Okay, what it means by a determinate limit. For limit x equals 0 for cosine x over x squared, if you substitute directly cosine 0 equals 1 and 0 squared is 0. 1 over 0 is infinity. 1 over 0 is infinity. So this part or this problem or this limit is not indeterminate style. So we have finished our work without using any rules, whatever the L'Hopital or another rule. We have finished our work, but we're gonna use some rules, or exactly today the L'Hopital rules, for just the limit of the indeterminate type. Let's see how. Okay, how to use the L'Hopital rule and why. Let's see. The L'Hopital rule, if the limit is in the form a quotient way, f up over g down, function up over function down, in the form of a quotient, we can determine the limit in another way if this part first indeterminate, or also it's hard to solve using another rule. We can find the same limit by find the derivative up and find the derivative down, then determine the limit after that. So L'Hopital rule tells us to determine the limit of the two functions in the form of a quotient way, in another form with the same limit for the two functions after derivative ups and downs. How to do that? Let's see. First, we have an example here. How to determine limit when x tends to 0, when x tends to 0, x squared over sine x. After replacing x by 0, it becomes 0, and sine 0 equals what? 0. 0 over 0 is indeterminate type. So we can use another rule. Let's use the L'Hopital rule, cause it's very, very easy and sufficient to determine this limit instead of the original ways. The limit was x squared over sine x when x approaches to 0. Let's use the L'Hopital rule to determine the derivative up which is 2x, the derivative down, which is cosine x, and replace x by 0. 2 into 0 is 0, cosine 0 is 1. Oh my god, this limit becomes 0 instead of indeterminate style. So we have finished our work. Thanks for L'Hopital rule. It was very easy to determine the the limit after derivative ups and downs by the L'Hopital rule. Okay, another problem. Can we determine the limit when x approaches to negative infinity for 3x minus 2 over e power x squared? Yes, we can. Replace x by negative infinity. 3 by negative infinity is negative infinity subtracted minus 2, it becomes a negative infinity. E power negative infinity squared is infinity. Infinity over infinity means indeterminate style. So we have to resolve it well using several ways, but our today's ways and the easiest way is the L'Hopital rule. Using the L'Hopital rule, find the derivative here, it becomes a 3. Find the derivative here, e power x squared, derivative it is e power x squared into the derivative of the power, which is 2x. Replace x by negative infinity. 3 as it is. E power negative infinity is infinity. So it's a 3 over infinity. We know that 1 over 0 equals infinity. And 1 over infinity equals 0. So 3 over infinity equals 0. Thanks, we have a real answer, which is 0, instead of indeterminate answer before. Thanks for L'Hopital. But we have here some common mistakes, as we said before. Some common mistakes. Here is a great mistake. Find the limit for sine x over x plus 1 when x approaches to 0. When you replace x by 0, sine 0 is 0, 0 plus 1 is 1, 0 over 1 is 0. So you have finished. You have finished. Don't do anything else, whatever the rule, because the final answer becomes a real, not indeterminate style. So why we're gonna use another way? If you take an action and use the L'Hopital rule, sine x derivative it cosine and derivative of x plus 1 is 1. Replace x by 0, it becomes 1 over 1 with 1, which is wrong. Why? We already have a previous answer well, and the initial limit is not indeterminate. So don't use the L'Hopital because you have finished. It's okay. And now another problem. Let's determine limit x tends to infinity for this quotient. Okay, we have a previous way. We divide by the greatest power in the numerator and the denominator, and the answer will be 3 over 5 directly. But if you're gonna replace x by infinity, the answer becomes ab infinity over infinity, infinity over infinity, also 0 over 0. Both means we have indeterminate solution, so we have to use another way. Already we used one way before, but now we're gonna use the L'Hopital theorem or the L'Hopital rule to determine the limit. Let's start by determine the derivative of the first function. 3x squared becomes 6x. Here is 1 and 0. 10x plus 8 plus 0. Oh my gosh, if we replace x ups and downs by positive infinity, the resultant will be infinity over infinity. Yes, we can determine the limit of f double dash up and g double dash down. So do the derivative once more. Derivative 6x is 6, derivative 10x is 10, so the final answer will be 6 over 10 or 3 over 5. Here we have a limit of e power x minus 1 minus x squared over 2 over x3. If you replaced x by 0 ups and downs, the resultant becomes 0 over 0 unspecified, which is indeterminate style. So we're going to use the L'Hopital rule. Up, derivative e power x is e power x. 1 is 0. Negative x is negative 1. X squared over 2 is negative x. X power 3 is 3x power 2. So replace x ups and downs by 0 becomes 0 over 0. So the first derivative not sufficient. Let's do the second derivative. E power x is e power x. 1 vanish. Negative x is negative 1. 3x squared is 6x. Replace x by 0 becomes 0 over 0. The second derivative not sufficient. Let's do the third derivative and don't worry. Derivative e power x is e power x. 1 is vanished. 6x is 6. Replace x by 0. E power 0 is 1 over 6. Final answer 1 over 6. So we have finished our work. Don't forget, we can use the first derivative ups and downs. If it's not sufficient, find the second derivative ups and downs. If it's not sufficient, find the third derivative or more. Here, what about the product? Oh my God, the limit here is product. It's not like a quotient style, f over g. Can we rewrite this style, this product style, into another style like the quotient? Yes. You know that e power negative x, we can write it as 1 over e power x. So it becomes x up and e power x down. Let's see how. If we're gonna find the limit when x tends to infinity, he said, for x e power negative x, I can write the limit for x tends to infinity. It becomes x over e power x. Replace x by infinity. It becomes infinity over infinity, which is indeterminate type. So we can determine the derivative up and down. The derivative x of 1 is 1. E power x is still e power x. So replace x by infinity. E power infinity, sure it's infinity. 1 over infinity equals 0. So we have finished our work and we rewrote the product style into division style or quotient style. So we for what to use the L'Hopital theorem or the L'Hopital rule in an easy way. Here we have another product, but you know this product is not product. We can rewrite it as a quotient. Cotangent to x, we can rewrite it as 1 over tangent to x. You know that? Okay. I wanna make the pen here. Little sine 6x over tangent to x. Instead of what? Instead of cotangent. So I can determine the limit well, but after replacing x by 0, it becomes 0 over 0. Sine 0, 0, tangent 0, 0. So we have to what? We have to find the derivative up and derivative down using L'Hopital rule to find the limit. Let's see how. I rewrote cotangent to x in the form of 1 over tangent to x and replaced x by 0 becomes 0 over 0, so it's wrong. I have to rewrite the limits. Using the L'Hopital theorem, I can derivative up. Sine 6x becomes cosine 6x into 6, the derivative inside. Tangent to x is secant squared to x into 2. Replace again. Replace x by 0. Cosine 0 is 1. Oh my God, it's 6 by 1. Secant 0 is 1. It's 2 by 1. So it's 6 over 2, which is 3. It's very easy. And now we have a difference. Last lesson. Last part in our lesson. A difference between tangent minus secant. Oh my god. If you replaced x by pi over 2, which is 90 degrees, tangent 90 is infinity and secant 90 is infinity. So it's undetermined. Undetermined, what it means? It means like I have to rewrite it. Using what? Using the L'Hopital. L'Hopital cannot determine the difference or the product. L'Hopital for only the quotient. Can I rewrite this style into quotient form? Yes. Yes. Replace tangent x by sine over cosine. Okay. Replace the secant by 1 over cosine. Yes. And find the common denominator. It becomes sine x minus 1 over cosine. Let's see how. Already, we can rewrite it in the form of sine over cosine instead of tangent minus 1 over cosine instead of secant. It becomes sine minus 1 over cosine. Sine minus 1 is f, cosine is g. L'Hopital allowed. Let's see how to use L'Hopital. Find the derivative up, which is cosine. Find the derivative down, which is negative sine. And replace x by pi over 2. Cosine 90 is 0. Sine 90 is 1. So it's 0 over negative 1. Becomes 0. Thanks for you. Yeah, we have finished our work without any effort after replacing the different style into quotient style. And already I wanted to just take a summary, take a tour about our lesson. We learned something about how to determine the limit for the quotient when it's like equal 0 over 0 or infinity over infinity. We can use another way to determine the limit, this way called L'Hopital. L'Hopital convert f and g into f dash over g dash and find the limit after that. If it's still 0 over 0 or infinity over infinity, please find the second derivative and so on. If the function is product, try to make it division. If the function is addition or subtraction, try to make it also division to use the L'Hopital theorem, which is appropriate and efficient for us. Thanks for listening. Assalamu alaikum wa rahmatullahi wa barakatuh.